Assalamualaikum. My registration number is 20T23, and in lab 7 we have to do frequency analysis of digital signal sequences. In task number 1, the basic objectives of this task is to study digital sequences in terms of frequency spectrum and contribution of high frequencies and contribution of low frequencies. We will check both cases in low frequency and high frequencies. In task number 1, there is a signal which is given, and we have to plot the signal in MATLAB. If sampling frequency is 20k sampler per second, then what we have to check? We have to redraw the sequence after removing frequency above 5k Hz, and then we have to redraw the frequency after removing frequencies above 7k Hz. So we will discuss both of the effects. First, in first task, I have taken the signal which is input signal, and the second is sampling frequency which is given in the input, which is 20k Hz, and the second one is the time axis. If I run this code, then I will get this type of original signal. This is the original signal, which is original input. Now the two cutoff frequencies are given. First one is 5k Hz, so I have to check 5k Hz cutoff frequency, and then I use normalized cutoff frequency, which is frequency divided by sampling frequency divided by 2, and then I used low pass filter to normalize the cutoff frequency. And if I run this code, then I will get when I remove this frequency, the effect of removing frequencies above 5k Hz is that the high frequency components of the signal will be attenuated or eliminated. So in the plot, you will observe that the high frequency of the sequence, frequency of oscillations and details present in the original signal, and the resulting signal will be reduced bandwidth. So this is the after removing frequency signal. So next one is the second cutoff frequency, which is 7k Hz, which is also given. So I have taken this signal, and then I have applied the filter signal. After removing this frequency, we will observe a further reduction in high frequency components compared to a previous case, and the resulting signal will have even smoother variations and potentially lose more higher frequencies. You can see in this figure. The next task is task number 2. In task number 2, we have to use these following audio sequences, and we have to calculate three things. First, DFT, and second, remove the upper half of frequencies, which is frequencies above fs divided by 4, and third, we have to remove the lower half of the frequencies. So we will check both of the cases. So in second task, the audio sequence is given, and we have to calculate three things. Calculate discrete Fourier transform, and we have to remove upper half of the frequencies, and then we have to remove the lower half of the frequencies by listening the audio. The audio which is given is, you can listen this. In MATLAB, we have to upload this music in the MATLAB drive. Here is the music.wave which is uploaded here. Replace the audio file.wave with the path of your audio file, and then we have given this command. Then we have to calculate the DFT, and secondly we have to compute the discrete Fourier transform of the audio signaling using FFT command. So after running this, we get this type of sequence. In next step, we have to remove the upper half of the frequencies First we have to determine the corresponding frequencies to half of the sampling rate, and then we have to set the we have to calculate the index of the frequency component that corresponds to fs divided by 4, and then we have to set the upper half of the frequency components like based on fs by 4 to 0, and by removing this upper half of the frequency we will get the sound like this. When we run this code we will get very slow sound music. So the music sound and its speed was very slow by removing upper half frequencies. So we will move towards the next, which is we have to remove the lower half of the frequencies. If we remove upper half of the frequencies, music will play very slow. But if we remove the lower half of the frequencies, first we have to set the lower half of the frequency components below fs divided by 4, and then inverse the Fourier transform, and then we have to play the music. So when I run this code we get another type of sound. So that's all from my side.